All right, so here's our last section, which is section 5, which is nothing more than just solving proportions and their application. So first, I want to go over what a proportion is. So in general, a proportion, okay, in its simplest form, is a fraction equal to another fraction. That's how simple it is. So the easiest situation is this. Whoops, A over B equals C over D, okay? Now, what you're telling me here is these two fractions are equal to each other in some way, okay? Now, there is one little exception here, which is B is not allowed to equal 0 and D is not allowed to equal 0, and that's because they're in denominators, but you really don't have to worry about that. The key to about a proportion, it's all about the setup. Okay? So, for example, if you want to create a proportion with miles per hour, notice I have miles per hour as a fraction, which means if you're setting up the proportion, the units have to match. Okay? Units must match. For some reason, I see students flipping it, and I'm like, what are you doing? That's not a proportion. You've completely changed the problem. So, real quick, we're going to do one example of just setting up a proportion. So, set up the following proportion. All right. And it's a really simple one, okay? 5 hits in 8 at bats is the same as 30 hits in 48 at bats. Okay, so here's our first fraction, and notice the units are 5 hits over 8 at bats. That has to equal, remember, the units and the setup is what is crucial here. So this has to be hits and bats also. And here's our second fraction. So it's going to be 30 hits and 48 bats. Okay? All right? That's how proportions work. All right? Now, excuse me. If you want to, you could take this one step further. How do we know these two things are equal to each other? Well, how do we know 5 over 8 is equal to 30 over 48? The easiest way to answer this question is cross multiply. Okay? Now watch what happens when I cross multiply. I'm going to rewrite the problem right here. Give me a sec here. While my computer's acting dumb. I'm going to write 5 over 8 equals 30 over 48. I'm going to take 8 times 30. And I'm going to tell you that it's equal to 5 times 48. So what's nice is we live in a world where we have a calculator, so we could do this real quick. 8 times 30 is 240. I don't know why that disappeared on me, because I'm going to need it again. So now I'm going to do 5 times 48, and watch what you get. 240. So, proportions, it's all about the setup. You got a fraction equal to a fraction. And how do we verify that these two fractions are equal to each other? We cross multiply. Okay? So if that's the case, then you can solve problems. Here's a really easy one. Let's solve x over 63, which equals 4 over 7. Okay, well, notice you got a fraction equal to a fraction, which means you can cross multiply. So that's exactly what I'm going to do. So I'm going to take 7x, and I'm going to set that equal to 4 times 63. Now, we know 4 times 63 is going to be 252. So the only thing I need to do here is just divide both sides by 7 to solve for x. So x is going to be 252 divided by 7. 252 divided by 7. 36. And that, like I said, that's a beautiful thing when you think about it. And what's nice is you recognized at the very start that you had a proportion, a fraction equal to a fraction. And when you have that, cross multiply. Okay? But you can even extend this even further. Look at this. Remember that thing about the units that I was talking about? Here we have a triangle. That side is 3, and that side is 4. Here we have another triangle. It's even bigger. Now, what I don't know is the height of this triangle. But what I do know is that, excuse me, this is going to be 48, whatever it is, feet. We'll say feet. All right, so feet. All right. Now, I can use proportions to solve this problem. Here's what I'm talking about. Actually, let me use a highlighter. I think a highlighter will be better. So this length is proportional to this length. And how do I know that? Well, I drew the triangles the exact same way. So that is going to, so because they're drawn the same exact way, I can say these two things are equal to each other. I can also do the same with the bases. These are going to be equal to each other. So what I can do here is I can set up a proportion as 3 over 4 equals x over 48. And now I can cross multiply. So I get 3 times 48 equals 4 times x. Now, 3 times 48 is equal to 144 equals 4x. And then if I divide both sides by 4, I get x equals, so 144 divided by 4 is 36. So I know this height right here is 36 feet. And to be honest with you, that is how surveyors figure out how tall certain buildings are when they're trying to build stuff. All right? There's the very famous problem is this problem right here. Here's the famous problem. It is, let's see here. Here's a building. All right, you're going to see my awesome artistic ability. All right, so here's a building, and the building is casting a shadow. (1,000 feet long). Okay, so this is the building shadow. Okay, so just draw like a little building here. There we go. All right. Now, you have a person that's standing all the way over here to the right-hand side, and this person, we know, is 6 foot. Okay? Like, you can measure that person. I'll zoom in. All right, 6 feet. And this person's shadow is 15 feet long. The question is, how tall is the building? Okay? Well, it's a proportion problem. What I'm going to do is I'm going to draw what looks like to me a triangle. So notice here I have 2 triangles, just like the previous problem. I have no idea how tall the building is, but I do know the shadow is 1,000 feet. So I can create proportions. X over 1,000 equals the height of the man, 6 over his shadow, which is 15. So from here, I can go ahead, cross multiply, and figure everything out. So if I cross multiply, I get 15x equals 6 times 1,000, or 6,000. Divide both sides by 15. X equals 6,000 divided by 15. 400 feet. And that is exactly how tall that building is. It's 400 feet tall. Okay? I gotta be honest with you. I absolutely love solving problems with proportions because it's very simple. It's just a matter of cross multiplying. All right. So here's another very famous problem. So we'll do this one. For every 1 kilogram of a child's weight, pediatricians prescribe 15 milligrams of fever reducer, so something like ibuprofen or something like that. If Isabella weighs 12 kilograms, how many milligrams of fever reducer will the pediatrician prescribe? Okay. So, like I said at the very start of this is all about setting up and understanding how proportions work. So here we go. Let me get rid of this. All right, remember, it's about setup. Units gotta match. So when we read the problem, what we're finding here is for every kilogram of a child's weight, you know what, let me use a highlighter here. I think a highlighter is better. So for every 1 kilogram of a child's weight, the pediatrician will prescribe 15 milligrams of fever reducer. So I'm going to write that as 1 kilogram of weight over 15 milligrams of fever reducer. Okay? Now, if this is the case, then the other fraction has to be the exact same. All right? So the question becomes, well, what does this other fraction look like? Well, that's where Isabella comes into play. So if Isabella weighs 12 kilograms, so 12 goes up top, how many milligrams of fever reducer will the pediatrician prescribe? Well, you don't know, so you put an X. But what we do know is now we got a proportion. So I'm just going to break it down into numbers. 1 over 15 equals 12 over X. And all I have to do is just cross multiply. So it looks like X is going to be 12 times 15. And when you take 12 times 15, you get 180 milligrams of fever reducer. And that happens every single day in the hospital. It's exactly what they do. Okay? So at the very start of section 2, we were looking at general application problems. So let me go back to section 2 so I can show you what I'm talking about. So we did this example here, which was, what number is 35% of 90, okay? And we did it the old school way, which is just using an equation. I think that's a little bit more difficult at times. But then in blue, I showed you this percent proportion. So we already have experience with proportions. It's just with the percent proportion, it's very specific. The amount over the base equals a percentage divided by 100. So the only thing that we had to do was figure out, okay, where did the numbers go? So remember, the base always comes after the word of. The percent symbol, you were literally looking for a number with a percent symbol. And then what's ever left after that will always be the amount. So it's like process of elimination. So what I'm going to do is I'm just going to go over a couple examples. I'm only going to do like 2 because we've already seen this before. Okay? But we'll keep it really simple. So 36 is 25% of what number? So remember, you got a percent proportion. I see the percent number is 25. I see the word of. Directly to the right, it says what number? So that's going to be an X, which means process of elimination, the 36 has to go in the numerator of the first fraction. Now, since we are going to use a calculator here, if you wanted to, you could reduce the 25 over 100. You could totally do that. But what I'm going to do is just I'm going to cross multiply right from the start. So I got 25x, and 36 times 100 is 3600. And then I just divide both sides by 25 to give me x equals, now remember, you got a calculator, so let's use it. So 3600 divided by 25 equals 144. So x equals 144. Now, the easy way to check yourself is to take your answer, substitute it in, and cross multiply. Now, we already know 36 times 100. We already know that's 3600. What's 25 times 144? That's easy. Just take 25 times 144, and you get exactly 3,600 again. All right, so I'll do one more like this, and then that's going to be it for this video. So it's a nice short one. So 175% of 84 is what number? Okay, well, like I said, once again, we're going to set up our percent proportion. I see the percent symbol, so 175. I see the word of. I look to the right. It's going to be 84. So process of elimination, what number goes up here? Once again, I'm just going to cross multiply. So that's going to give me 100x equals. Now, I do have to do that. I can't do that one in my head. So let's see here. What do we have? 84 times 175. It's going to equal 14,700. And then I just divide both sides by 100, and I can do that. X equals 147. And that's going to be it for this video. So like I said, short one. It's very simple. It's really straightforward. Proportions are all about the setup and the units that match. To solve, cross multiply. That's it for chapter 6. So I'll see you in chapter 7, which is going to be another short chapter. It's not hard at all. All right, bye.